Hi, in this video I will show how we can use the oscilloscope. First of all, we turn on the oscilloscope and we have to wait a little moment in order to the oscilloscope turn on. I will use the channel 1, is in yellow, and I will connect the oscilloscope tip, in this case, to the channel 1. We introduce the oscilloscope tip and turn in the clockwise in order to the tip have to engage to the oscilloscope. We will measure blinking LED. So, with help with the jumpers wires, we will connect the tip. First of all, I will connect the ground. After that, I will connect the signal of the first blinking LED. In this case, no, it's the other cable. Let me see. Yeah, this is the ground. After that, I will connect the signal of the first blinking LED. As you can see, in the oscilloscope appear a signal, a periodic signal. We can scale this signal using these scales. For G, for Y, X, we can move the amplitude of the signal. In this case, we have 5 volts per division. In this case, the microcontroller provides us a signal of 3.3 volts. And as you can see, the division of each is 5 volts, and the signal is less than this 5 volts. If I move the amplitude, in this case I have 2 volts per division, we can see that we have 1 division and half. And if I move another one, the amplitude, we can see that we have a 1 volt per division, and I have 3.3 volts of the signal. That is according with the microcontroller. And you can see that we can move the frequency of the signal. In this case, it is in the X axis. I can move it. We can notice that the signal frequency is more is less. In this case, I have 10 milliseconds per division, and you can see that the time that the signal is on is approximately 10 milliseconds. I have 10 blinking LEDs, so when I move the frequency, we can see that we have approximately between period between signals. Let me see. 1, 2, 3, 4. In this case, Let me adjust the signal. In this case, we will have let me do the signal less. We have 10 100 milliseconds, so the signal approximately, the period of the signal approximately is 200 milliseconds. We can see that I move the to 200 milliseconds, and you can see that is one division. So this is only for one channel, but we can use another channel. So I will connect the second tip and turn to clockwise, and I get the second signal to the second blinking LED. So I will connect the ground, and I will connect the signal, and I will turn on the second channel. And as you can see, we can see the both signal in the same with the same place. I will adjust the amplitude to one division per 1 volt per division, and I will adjust the frequency. As you can see, if I move the frequency, you can see the both signal in the same place. In this case, with this oscilloscope, we can obtain the measurement of two signals. This is important because sometimes you need to compare one signal with another signal in order to obtain some features. So this is the video. Thank you to watch me. See you.